Okay, hi everyone. I'll talk a little bit about UMA. I see that not many people know about the protocol, so I think it'll be useful to give a brief introduction on why we actually address the problem. So we started with how we currently share data on the web. So, like you go to a website, you just share the data, you disclose it, which means that you provision it by hand, you provision it by value, you basically overshare and you lie a lot. And that's a problem because obviously you end up with the data being in a number of different locations. So how does it happen where, we've approached the Web 2.0? Like we can now share the data between different parties and, we can impersonate users. We can get data from one location to another. And the problem is that, we use that or we address that with the credentials. So it's really not favorable because it's a honeypot for shared secrets, and the partners or the companies or the services that talk to each other with that sort of technology are sort of in the gray market. And then the OAuth came in. So, it recognized the fact that we could have clients that have the data, that want the data, and the resource servers or the servers that have the data, and that we can share data between these two. The problem is that as a user, you simply, when you transfer data from one location to another, you do agree to some meaningless terms. You have to go through this painful access management process because every kind of authorization page is different. And you still overshare because you have little control over how the data is shared and processed. OAuth 2 recognized that there's a difference between the server that really issues the authorization and the server that has the data. So we have this difference between the resource server and the authorization server. There's still a client that gets the information, but we still get this distributed access management that's across a number of different services. So I have my policies, my permissions for Facebook in one location, on Twitter in a different location. Obviously, there are some websites that try to address it, so they give you links to so that you as a user go and review all the permissions that you have. But it's really still a problem. And with party-to-party data sharing, what can we do? Like you have all kinds of different services where you really want to share data, not on your own behalf between services, but with other people on the internet, like the TripIt or Google Docs or Flickr. Well, we can use private URLs. You can send them to some other folks who want your data, but it's really not for sensitive data. Or we can, again, require impersonation, so you share the credentials. Or you can implement something proprietary, like Google does for their services. But if you think about how companies try to approach the authentication problem, how they want to get rid of the passwords, so getting rid of that, getting rid of the credentials that you can easily share, and you shouldn't, but you can easily share right now, then you cannot really do the impersonation anymore. And for IoT, which requires strong authorization, and with the scale that it has, like millions of devices being added every day, then new approaches are needed. But let's take a look again at the classic model, how you share the data, how you disclose the data. So you go to a website, you basically share the information. You have to agree to some terms. You really don't read those terms. Nobody does. And we all know that it's a big lie. And the businesses who operate still on misleading users, obfuscating how much data they get, and being opaque how they use it, what are the data mining techniques, etc., then they're operating already on the borrowed time. And the other thing is that we have to see that the privacy itself, or that the users don't care about privacy, is also a lie by itself. If you take a look at at healthcare data, obviously it's easy to show it on the healthcare data, but the convenience of accessing the data is less important to users than the privacy. And we know that the same principles applies to basically any kind of data, any kind of personal data. But for us, when we started building UMA, user managed access, we knew that privacy for us will not be secrecy. Privacy will be really selective sharing, so allowing the individual to be able to select what information will be shared at what time and for what purposes. And that's one of the quotes that one of the most important quotes that we took into account when we started working on the technology is that in this new modern identity, user-centric identity management system, we have to put the user in the center and allow them to quickly determine how information will be revealed, what information will be revealed to which parties for what purposes, and what the consequences will be. And that's all about the context controls, choice, and respect, which means that the user has to be able to make a decision at the right moment when they are in the process or are within a transaction. The control, so just share the right amount of information, the choice, so to be able to maybe revoke access at some point, and respect, to actually impose its own terms when the data is shared. And UMA became to the rescue, so it became to address all those challenges that I just presented. It is actually a profile of OAuth 2. So initially we aimed for UMA to be its own protocol, but we then put it on top of the OAuth protocol. And UMA defines how resource owners can control protected access by clients operated by arbitrary requesting parties, so clients being software and requesting parties being individuals or organizations, and where the resources reside on distributed set of resource servers, and where a centralized authorization server governs access based on policies which are set by individual users. This is the architecture, which is very simple. We have the resource owner, the authorization server, and the resource server, which has the protected resources, and the client, which tries to access these protected resources. And the client can be a web application, it can be a mobile application, but in the current version of the protocol, the resource server is usually a web application. And if we take a look at the OAuth protocol, so we have the client, the resource server, and the authorization server. The authorization server, resource server are really co-located, so there's no standard for the moment that allows these two to communicate outside of different domains. And UMA adds that kind of separation. So it puts the authorization server separately from the resource server, and the client, when it tries to access, protect the resources, it has to go to an authorization server, UMA authorization server, to get the necessary token, get the necessary authorization. And really importantly, the single UMA authorization server can provide its functionality to a number of different resource servers. So it's a kind of a different setting than in the OAuth protocol. And if you're more familiar with identity federation services, you can think of UMA as being this authorization as a service, like identity as a service is being used right now. So if we have a resource server and the authorization server, the resource server is really like an authorization relying party. So it delegates the authorization to some other component. So as in identity federation, we have relying parties, we can have authorization relying parties. And the authorization server is basically similar or an equivalent to identity provider. So it provides its services to a number of different client applications. In fact, the UMA authorization server is likely to be an extension of an identity provider. And just to give you a brief overview of example policies, which are outside of the protocol, but they can be used in UMA, is that you can share your data with specific people. You can name them, or you can share by requiring some promissory claims or asserted claims, self-asserted claims, or third-party asserted claims. And as I mentioned, under the hood of the UMA protocol, there's OAuth. So some people consider UMA as the OAuth++. And there are two instances for the moment. This may or may not change. We'll see about that. But the thing is that the resource server and the authorization server is a many-to-many relationship. So a single authorization server can provide its services to a number of resource servers. And also a single resource server, which has a number of different users, can interact with many different authorization servers. It depends on the user's preferences. And the other thing is that the requesting party, unlike in OAuth we have a single entity which shares the data from the from the resource server to the client. In UMA, the requesting party can be different from the resource owner. So it can be a different user, it can be an organization, etc. And the two instances of OAuth exist between the resource server and the authorization server, and the second between the client and the authorization server. And I'll explain them in a second. But the most important bit is how a client gets access to protected resources. Well, it does that by presenting some sort of information, some sort of a consent authorization to the resource server. And that's what we call a requesting party token. It's an important concept in UMA because what it does is that it basically tells the resource server, these are the permissions that I have. Can I get access to, I don't know, a picture or some personal information? And this RPT token, it bounds a number of different entities, the resource server, the client, the requesting party, and the authorization server as well. And as I mentioned, there are two instances of OAuth in the UMA protocol. One is within between the resource server and the authorization server. So it binds, it creates this relationship, this trust relationship between an application that's operated by a resource owner and the authorization server, and that's done through a protection API token. And the token allows for usage of some functionality at the authorization server. The other instance of OAuth is the one between the client and the authorization server, and this one allows the client to simply go and obtain authorization to access some protected resources at the resource server, and obtaining this authorization is done with the AAT, the authorization API token, another concept that is very important in UMA. So these protection API tokens and the authorization API tokens are really very important in the UMA space. They represent important UMA concepts. The protection API token actually represents the authorization that the resource owner gives to federate authorization, so delegate authorization from the resource server to an authorization server. The AAT represents the consent of the requesting party to actually provide some claims or to provide some information by the client to the authorization server to get to obtain the RPT token. And just to summarize, so UMA is a protocol for lightweight access control. It profiles OAuth 2. It's a set of authorization, privacy, and consent APIs. But also, it's a Kantara initiative working group. So we already made 2 recommendations, sort of standards, version 1.0, which was in mid last year, and 1.0.1, which was accepted December 2015. And the standard or the technology that we're building is still under further development, possibly towards version 2.0. And just to tell you, the specifications are as following. So we have the UMA core specification and what we call the OAuth 2 resource set registration specification. There's another version, as I mentioned, that we accepted in December. And also a new specification, which we call a claims gathering extension for enhanced security. There are some changes in the protocol that are being done. They are discussed within the working group, but it's important to mention that the current version of the protocol is ready for deployment. So there are already some pilot projects or some projects, production projects that use the protocol. The main changes are the alignment with OAuth 2 and OpenID Connect protocols, so that if you already have a deployment and you would like to add UMA, then it will be somewhat easier. We did some ticket rotation. Actually, we didn't touch on that, so I'm not sure if that will be clear. But some syntactical changes as well, and we basically plan to serve more and more use cases with every version of the protocol that we do. There may be some possibly breaking changes when the version 2.0 comes. And these potential changes is actually the removal of AAT, the protocol that, the token that I just mentioned, and one of the endpoints that allows for the RPT token to be issued, but these are yet to be discussed and approved. If you need more information, then please reach out to me after the talk or during the breakout sessions, and we have a working implementation that I'll be more than happy to show. And you can obviously sign up for the UMA work group. This would be great because we are always looking for new use cases. And you can follow UMA on Twitter and also see what's going on in the UMA space. So thank you for your attention.
Thank you.